So some quick review. We had defined potential energy as any type of stored energy. So even force times distance in a bow and arrow was potential energy. We had defined gravitational potential energy as the energy due to an object's position. That was mgh. I would have picked somebody, I don't remember who I picked here, and I would have done something with a bowling ball. Oh, of course, it was Gerard, and a tennis ball. We would have kind of derived the equation on our own. The more interesting one was kinetic energy. We were able to derive that a little bit. I haven't explained where the squared and the 1/2 comes from. If you're bored, see me. It's just a lengthy proof, and I didn't want to go into it. But I talked about how that squared dominates you in ways you don't realize. If you want an object to go twice as fast, you need 4 times 2 squared, the energy. If you want an object to go, for example, 6 times as fast, you need 6 squared, 36 times more energy. The faster you drive, the less efficient your motor, the worse your gas mileage, the more expensive it is. So people that drive fast everywhere, they're just throwing away money. We talked how that also, sorry? To a degree until you're the one paying the gas bill. And then you have to decide, okay, do I really want the fund or do I want to actually be able to spend the money on other stuff? We also talked about in accidents, if you're, for example, compare an accident at 80 kilometers per hour to 20 kilometers per hour. 80 kilometers per hour, there's 16 times the energy. That energy's got to go somewhere. There's 16 times the damage typically to the occupants. And it will take you 16 times further to stop. I like example 7. I like example 7. Example 7 is a nice question. Clover, what are they asking you to find? What did they give me? What's the 25? What's that 924.5? What type? How do you know? Okay, let's write down the kinetic energy equation because it's still newish. Eventually you'll probably do this in your head, but we'll really be meticulous in our notes. Kinetic energy is a 1/2 mv squared. I said it was worth memorizing. It is on your sheet, but it's worth memorizing mgh and a 1/2 mv squared. How many variables are there in this equation actually? 3. Kinetic energy, m, and v, which means how many equations does this actually technically contain? 3. Okay? 3 variables, 3 equations. Let's get the v by itself. How would I move the m over? Good. What about this 2 on the bottom? How would I move this 2 on the bottom over? Multiply. What about this 1 on the top? Technically divide, but am I going to really worry about that? No. So you're going to get this. 2 times ke divided by m equals v squared. V what? How'd I get rid of a squared? Yeah, this might look a little familiar when we had d equals a 1/2 at squared, and we got the t by itself. It was divide by a times by 2 square root. So kind of, we've seen this a bit before. We're not doing it right now, but it's the same kind of pattern. Now I can plug in the numbers. V is going to be the square root of 2 times 924.5 divided by 25. What'd you get? 8.6 units? Good. Not on the test, but just for nerd trivia. Is that fast? How many kilometers per hour is that? It's going to be something to do with the 3.6. 30. So you know what? That's school zone speed. Probably faster than most of you could run, but Usain Bolt is running 100 meters in less than 10 seconds. So he's averaging 10 meters per second, and probably at his peak speed is about 12. So this is probably a reasonably fast high school kid running, but not an Olympic athlete. Or you're pedaling on your bike with some intensity, but not a lot of intensity. Okay. I like example 8. We're going to talk about roller coasters, but actually, I can't quite say I like example 8. I like example 8. I'm giving you more information in this question than I eventually will. We'll learn how to really analyze roller coasters. But it says this: a roller coaster has a kinetic energy of that at the bottom of the first hill. Okay. Oliver, what's A asking me to find? You know what? They gave me mass and kinetic energy. I think it's going to be really similar to the one that we just did. It's going to be KE equals a half mv squared. And I'm going to get the V by itself. How would I get the V by itself, Oliver? How would I move the M over? How would I move the 2 over? What's the 2 doing to the M and the V and the 1? Adding, subtracting, multiplying, or dividing? The 2 is multiplying? Is it on the top or the bottom of the fraction? So, it's not multiplying. You know what it's doing? How do I move it over? Okay? So it's going to be V squared equals 2 times the kinetic energy divided by the mass. Oliver, how to get rid of a squared? So I will often do this when I'm standing in line for a roller coaster I love roller coasters. I'm nuts about them. And I do think it adds to the experience if I can work out roughly how fast I'll be traveling at the bottom of the first hill. What'd you get? Could somebody convert that to kilometers per hour? Is that a fast coaster? Sorry? 101? I'll stand in line for maybe an hour for that, but not for 3 hours. I've been on far faster coasters than that, but that's pretty good. Freeway speed? Okay, I'll enjoy it. It's not going to be boring. Now let's talk about some ride design. Suppose you're a ride engineer and you know you want people at the bottom of the first hill to be going 28 meters per second. Well, how high do you need to build the first hill? That's a good question. Gibson, can you read to me the first phrase? Starts with the word if. Look up. What I'm really saying is, if this is true, that's my starting point. If all of the kinetic energy came from potential energy. No, I'm almost done. Then you can go. Wait, please. Now, I know the kinetic energy, Gibson, as a number exactly. What was the kinetic energy as a number exactly? What's my equation for potential energy? mgh. Gibson, what do you think they want me to find? No, kinetic energy is 137,200. Read the question. What do they want me to find? H. I'm going to get the H. How would I get the H by itself? How will I get the H by itself? I'll multiply mg over. What are the m and the g doing to the h right now? Sorry? Okay, we got to remember our formula manipulation skills, right? H is going to be 137,200 divided by mg. It's going to be 137,200 divided by 350 times 9.8. All of you should try crunching that on your calculator. Every one of you. I think you'll have to put the bottom in brackets because I think there's more than one thing in the bottom. Gibson, let me know what you get when you're done. Okay. So if you're designing a ride, oh, by the way, what I do then when I'm standing in line, I estimate the height of the first hill, or sometimes if I'm really bored, I'll use trig. Once I have the height of the first hill, I can calculate how much kinetic energy. Once I have how much kinetic energy, I can calculate how fast I'll be going. I usually, instead of 9.8, I use 10 because I'm usually doing the math in my head. And I can usually, I'll bet you I'm probably within a few meters per second of the actual value. We're ignoring air resistance and friction and things, but it should be pretty close because they grease those coasters down pretty good. Ooh. Example 9. Colton, what's example 9 asking me to find? Height. And it looks like they've given me a potential energy. You know what? I'm going to write down the potential energy equation. PE equals mgh. Colton, my friend, how would I get the h by itself? What are the g and the m doing to the h? I'll divide it over. H is going to be PE divided by mg. It's going to be 15,288 divided by 65 times 9.8. Sorry? Should be 24. Anybody else? Yeah. So where might you use this? Next page. You might use this, for example, in industry if you're building something. You folks might remember when you were about 6 or 7, that when they were building the Golden Ears Bridge, there was pile drivers going on for about a year and a half or 2 years. They were pounding pilings into the riverbed because they needed some firm structures on which to attach stuff. So suppose we want a 2,500 pile driver to hit the ground at 18 meters per second. The soil engineers have looked at the soil in this location and they've said, okay, if you want this to move in, you need to hit it at 18 meters per second. First question, Tyler, what's part A asking me to find? What's my equation for kinetic energy? By the way, it's speed, and we'll just, instead of saying a half times mass, we'll just say a half mv squared, and we'll all know what you mean. But it is speed. So it's going to be 0.5 times 2,500 times 18. Don't forget the squared. Crunch the numbers for me, Tyler. How much kinetic energy do we need? And don't give me a rounded off answer, because I think we're going to use this for B and C. Even? Nice. 405,000 joules. Now that's a fair bit of energy. You would not want to be under that pile driver. It would squash you. 1,000 joules you can usually absorb pretty good. 400,000 joules, not so much. It would depend on the mass of the car and the speed of the car. So ask me that after and we can run some numbers. If all of the kinetic energy comes from potential energy, how high do we need to raise it? So I think what we're saying is this. If all of the kinetic energy, 45, Mr. Duke, 405,000, comes from potential energy, I think the potential energy has to be 405,000. But Noor, what's the equation for potential energy? What's this question asking me to find? How?
Divide the equation by.
Good. So it's going to be 405,000 divided by 25. By the way, look up. In terms of showing work, look up. I'm fine if you just go like, look up. Keep looking up. I'm fine if you just do that. I'll figure it out. You don't need to rewrite the equation. So I'm going to go straight to numbers. It's going to be 405,000 divided by 2,500 times 9.8. I don't think I made this one work out evenly. Sorry? 16.5? Round it off properly? Yeah? That's meters. So here's the question. Suppose you walk out to the job site and you need 16.5 meters of height to drop this pile driver down, and you realize there's a tree in the way. It's overhanging, and it's an old tree. You don't have permission to cut it down. You can't raise the pile driver 16.5 meters. You can only raise it 12 meters. What can you do? Nope. I can't increase the speed. Have we talked about power at all here? Power is work over time. Remember, that's a specific physics concept. What else can I change? What, Brian, what? Yeah, then I need to realize I can't have a 2,500 kilogram pile driver. I've got to bring in a different machine. This is some of the, and this is very basic, it's much more complicated than that, but this would be some of the mechanical or industrial engineering that would go into designing a job site. You would look around at obstacles and things and, oh, okay, we can't go as high as we want. Well, we can increase the mass, just bring in a bigger pile driver. Okay. One more, we're done. Ooh. Gerard, what are they asking me to find in this question? What did they give me? Let's not write out KE equals a half mv squared. It's on our green sheet. Look at it on your green sheet and get the m by itself. First of all, how would you move the v squared over? Well, after that, I guess I'm going to have to write it out, because the good news is at least you didn't say subtract. Okay, let's try this again. I guess we're trying to get the m by itself. The KE is going to drop down like a domino. How will I move the v squared over? Good. How will I move this 2 over? How will I move this 1 over? Who cares? So I'm going to get this. I guess m is 2ke divided by v squared. Do I need to square root? There's a v squared. Do I need to square root? Why not? Okay, there's no squared on the m, and I'm trying to get the m by itself. So, by the way, in the previous question, you could use this to figure out what new mass you need. It's going to be 2 times 1,764 divided by 7, don't forget the squared. What does the mass end up being, Gerard, my friend? Oh, I thought you had an answer already. That seems completely wrong. First of all, before I show you the short video, homework. I told you yesterday I was going to assign every question. I fibbed a little bit. If you scroll down, you can cross out question number 16, A, B, and C. But the rest of them you can try, and it looks like I left you some room. If you write small, you can probably write on this sheet. Hang on one second, please. Pause for a second.